graph the one we skipped, y equals sine 2x. I don't believe this one is in your notes. And then we can compare it to the graph of y equals sine x. All right, so let's look at this graph first. All right, and then we'll look at this graph. All right, so the amplitude is the coefficient in front of sine. If we don't see a coefficient, that means there was no change to the amplitude, it's just 1. Right, so our amplitude is not changed. The period for the graph of sine or cosine is found by taking 2 pi and dividing it by b. B is the coefficient there in front of x, so b is 2. That means the period is 2 pi divided by 2, or pi. Right, so we have the new period, we have our amplitude. There is no phase shift or vertical shift because nothing is added to x and nothing is added to the whole function. All right, so the only thing that's changed between our two graphs, y equals sine x and y equals sine 2x, is the period. The period of y equals sine x would be 2 pi. The period of y equals sine 2x we just found, and that would be pi. Right? So it goes through the important points twice as fast. All right, so now let's find our x values. This is going to be old x. We'll find the new x values, which is the period change. And then we have our y values. Right? Now, y values are those values that go with the old x values. Our original x values for the graph of sine x or the graph of cosine x is always going to be 0, pi halves, pi, 3 pi halves, and 2 pi. They're the quad angles as we go around the unit circle. All right, so when we think of sine, sine is opposite over hypotenuse, right? So at 0, sine would be, the opposite is 0 on the x-axis, so 0 over 1, that's 0. And then on the y-axis, right, so now when we're on the y-axis, sine is now at 1, and 1 over 1 is 1. At pi, now we're back to the x-axis, sine is going to be 0. At 3 pi halves, we're on the negative y-axis, so that's going to be negative 1. And then at 2 pi is the same as 0. We're back around the circle again. Right? So those are our y values. And those y values are not going to change because there was no amplitude change and there's no vertical shift. Those are the things that change the y value. To find our new x value, we need to adjust the x values for the period change. Right? To do that, we need to know what to count up by. We take the period. In this case, the period was pi, and we're going to divide by 4 because all the important points happen 1/4 the way, right? Because the quad angles, we're going 1/4 of a circle. So all the important points happen at 1/4 the way. So to find our new x, anytime there's a period change, you're going to take the period and divide by 4. All right, so now pi fourths is where every pi fourths, something important is going to happen for our graph here. We start at 0, and then we count by the period over 4, or in this case, by pi fourths. Right, so we're starting at 0, and then 1 pi fourth, 2 pi fourths, and of course 2 pi fourths is the same as pi halves, and then 3 pi fourths, and 4 pi fourths. And of course 4 pi fourths is the same as pi. Notice that our last value matches the period, right? Those two have to match. So this and this must match. If they don't match, you counted wrong, you skipped something, you added wrong, something happened, right? So now we're going to graph the points for y equals sine 2x. and we're going to graph the points for y equals sine x. So I'll graph in, actually I should switch these because I wrote the period change in red. So I'll graph y equals sine 2x in red, and I'll graph y equals sine x in blue. So let's graph y equals sine x first. All right, so for y equals sine x, this is going to be the x, and this is going to be the y. So I'm going to have the point 0, 0, just our base graph for sine. And then I'm going to have the point pi halves 1. And then we'll have the point pi 0. And then we'll have the point 3 pi halves negative 1. Right? So notice here's our sine curve, right? It's going to keep oscillating between negative 1 and 1. And then we'll have the point 2 pi 0. Right? And so here in blue, let me try not to miss my points. Let me just fix my graph. It's up just a little high. I overshot the points just a little bit. There we go. In blue, we have the graph of y equals sine x. And we should put arrows because it's going to keep doing the same thing forever and ever and ever. Whoops. The arrow and the name of the graph got connected. I don't know how that happened. All right, so now let's graph y equals 2 sine x. This is going to be the x values because we had a period change. So we're going to graph the points 0, 0, pi 4ths 1, pi halves 0, 3 pi 4ths negative 1, and pi 0. All right, so we have the point 0, 0. Still going to go through that point. And then pi 4ths 1. All right, so now I'm going to be halfway between those, so I'm going to be right here. And then pi halves 0. And then 3 pi 4ths negative 1, so halfway between. And then pi 0. So you can see that y equals sine 2x goes through the cycle twice as fast. Let's do the domain and range, and actually the domain and range is going to be the same for both graphs. Always the domain is going to be negative infinity to infinity for all of sine and cosine. Right? It's just continuous along our x-axis there. The range is, both of these graphs are oscillating between negative 1 and 1 because there was no change to y. There was no amplitude change and there was no vertical shift. All right, so that's the end of this graph. Thanks for watching and bye for now.